Hi, and welcome to this new video about semantic kernel, where I'm going to show you how you can use logging interceptor and HTTP call interceptor to understand what's going on under the hood of semantic kernel. And this is because you have one option that allows semantic kernel to automatically invoke the plugin. So it's like creating a virtual assistant where you allow the assistant to use plugin, and then you perform a task, you ask something to the assistant, and the assistant is able to understand how it can solve your question using the plugin. And so everything is automatic. It's like building a copilot with very few lines of code, and it is fantastic, but sometimes there's some problem, and that's where things gonna be difficult. Basically, the problem is you give a question to semantic kernel and the result is not what you expected. So you need to understand what's happening under the hood, what is behind the semantic kernel interface, because that allows you to be able to diagnose what is happening and understanding if maybe your plugin got a wrong description or the description is not so good, so semantic kernel is not able to understand which plugin to use, and so on. And also, it will be a very interesting way to understand how you can use GPT in a slightly advanced way to force him not to give a textual response, but actually to give you a function and a JSON argument well-formed to perform task. And in this video, I'm going to briefly show you the code that you can use to intercept any call and being able to parse the call, giving the user a nice UI to understand what's going on. And all the code is fully available on GitHub on the description below. And you can use and run and try for yourself. And I'm gonna give you the key concept and where you need to look in the code to understand what's going on. The first piece of important code is where I'm going to configure semantic kernel. And in that specific configuration, I'm gonna add a nice class called dump logging provider. And this class will be able to intercept all the logs that semantic kernel is generating so we can save and store for later use. This class inherits from a simple interface iLogged provider, and it is able to intercept all the logging of all the applications so you can store for later inspection. So it is useful because it allows you to intercept all the logs and understand what is going on. But in this specific situation, instead of intercepting all the log, the first thing I really like to do is intercepting all the HTTP call that semantic kernel is doing to the OpenAI REST endpoint. So we can intercept, and we can understand how semantic kernel interact with Azure OpenAI or OpenAI services. This is really simple because the ASP.NET has a structure that it's very pluggable and expandable. So you are able to register an instance of an HTTP request body logger. It's a special class that can intercept any HTTP request that the software is doing. So that is the very first point of inspection that I need to plug in to understand what's going on and to understand how to troubleshoot if semantic kernel is not giving me the result I'm expecting. The class you need to use is a class that implements the HTTP client async logger. And it's a class that gets called whenever there is a request and a response of an HTTP call. So as an example, in this code, you are looking at the code that intercepts the request. And I'm simply looking at the endpoint. And if the endpoint contains OpenAI, it's a small and stupid heuristic, but this disambiguates me from HTTP call to other service. If the service contains OpenAI, I'm just going to intercept and enable content inspection so I can understand which is the exact request that semantic kernel is doing to the GPT endpoint. I don't want to go too much into the detail, but it's really simple. I just need to intercept the request and place into an object that I call LLM call. It's a simple object that is capable of understanding and keeping the content of the request. And when the request ends, okay, I need to simply look at the header, because all the requests that were done by semantic kernel have a special header by Microsoft. Is a XMS client request ID, and this is able to correlate the response with the request. So I was able to understand the request and to append to the very same LLM object in memory all the information about my request. And basically, I only need the payload of the request and response that is a simple string. Given this, I'm able to have a correlation key for all my calls to semantic kernel, and I've built a simple class that helped me diagnose what is happening. And it's very simple because you can look at the code. It's simply a parser of the JSON request and JSON response just to extract some important information to give me an idea of what is happening. So there is nothing complex. I just intercept all the requests, I intercept all the response, I correlate the response to the request, and I have simple class that are capable of understanding the JSON of the OpenAI payload, answer and response, and request and response, so I can show to the user in a much more human readable format. The only key part of the whole interceptor is this specific call that it's able to start a correlation. So the problem is when I'm doing a question to semantic kernel, and if this is a service that I'm using in one of my software, there is the possibility that multiple users perform a contemporary call to my kernel object to solve different questions. So I have various calls to the large language model, and I need to be able to correlate all the calls that are part of a single question. If I'm not able to do this, the intercepting is almost not usable. So as you can see, I simply give to this dump login interceptor the ability to specify from external code a correlation key that I'm storing into a special variable. The correlation key is a variable of type async local. It's a very, very special variable that allows you to specify a value that is kept during a same call. So I start in a thread, but whenever I'm going to interact with a large language model, we have a sync and await because, we are making HTTP call. So the situation is I'm starting with a thread, and when I'm performing an async call, I can come back to a different thread. So to ensure that during the a certain sequence of calling of a thread that jump with async await, the async local gives you the ability to set a value, and that value will be kept during subsequent async await call. So if you have multiple entry point in a controller, as an example, where two user perform two different questions, if each call generate a new guide, as an example, and store inside this correlation key, each flow of the two different interaction will have two different value of this correlation key. And this gives me the option to perform a question and give back to the user the answer and the correlation key that the user can use to query the system and understand what's going on. As you can see from this video, I simply create an endpoint where I can ask something to semantic kernel. And in the situation, I'm asking to extract audio from a file, and it answered with the answer and also the correlation key that I can use to understand which was the sequence of call to GPT that brings me from the question to the answer. As you can see, if I'm asking a little bit more complex question, like I want to extract the transcript from a video, it gives me a much more complex response. And if the response is not what I'm expecting to have, I have the correlation key, and now I can use to understand how semantic kernel interacted with GPT. Thanks to the correlation key, I have another endpoint that I can use to understand what's going on. As you can see, the answer gives you detail on what's happened behind the scenes. But yeah, it's not really usable. So I've created a simple interface in Blazor that helps you visualize what is happening, and it's useful for testing your prompt in semantic kernel. As you can see, I have a nice interface where I can perform a question like, I want to extract audio from file, and I press do question, and semantic kernel answered the question for me. But you see, I now have some debug information. Thanks to my HTTP interceptor and my parser, I was able to show that we had indeed two distinct calls to GPT. The first one that has the same question as a prompt, and as an answer type, you have a tool calls. So actually, semantic kernel asks to GPT, hey, user gives me this question, and GPT told back, you need to call this tool, the audio video plugin extract audio. And that is indeed the right tool for the job. But to understand how this works behind the scenes, we need to look at the raw request and raw response to understand this kind of interaction with GPT. Selecting the raw, I can look at the very raw request. So I'm looking at the JSON of the request to GPT. And as you can see in the very top, you have the prompt. So that's the question of the user, its role user and content. And then you have a special section called tools that is the new way of calling function call. In this section, I'm not going to explain to you in great detail what's going on, but in this section, you can specify to GPT that you indeed have external tool. GPT is not absolutely able to call that tools, but it will examine the list of tools you are specifying to understand if it can solve the question you give with one of the tools. And if the response is affirmative, instead of answering you a text answer, it can give you the tool to call. At the end of the list of the tool, you have the tool choice set to auto. It means, hey, GPT, you can scan the question of the user, and if one of the tool is okay, you can give me as an answer to call a tool. And if you determine that no tool is it's gonna solve my problem, you can just answer me some textual answer. And this is the response, is the answer. As you can see, it is really, really different from a standard answer. You have the choices part of the answer, but in this situation, you don't have a textual answer. You have a finished reason equal to tool calls. So this means that the answer of GPT was generated because it determined that you can solve the problem using one of the tools you specified in the request. And so you have a message with the role of assistant, but instead of having text, a message, you have a tool calls, where GPT is going to tell you which is the function you need to call. And in this situation is my audio video plugin extract audio. But the most important things is GPT specify the arguments. It analyzes all the text of the user. It determines which is the correct argument to pass to the plugin because you specified the description of all the parameters. So GPT is able to understand where in the text it's the right part to pass to the function, and the argument is JSON, and it's a well-formed JSON. You can expect to always find JSON, and the JSON is conformant to the parameter description you gave into the request. So that is the magic that GPT is doing. You can give a prompt, a textual prompt by the user. You can give the list of the function with all the detail of the parameter. And you can be sure that if GPT determines that one of the function is okay to solve the problem of the user, it can give you the name of the function to call and a JSON parameter arguments to pass to that function that is well-formed and adherent to the configuration of the schema you passed in the request. Now you can see that after semantic kernel asked to GPT, hey, that's a question of the user, these are the tools, what do I need to do? GPT answer called the extract audio plugin. GPT called, semantic kernel called the extractor plugin, and then it came back again to GPT asking a new question, and this time the answer type is stop, and that is where semantic kernel understand that everything was done correctly and it can stop. Let's look at the detail. This time the structure of a message, it's really, really interesting. There is the first message, it's a message from the user, it is the original question. Is I want to extract audio from a video file. Then it comes a second message, and this time the role is the assistant, and it's the chat. It's what happened before. So the assistant told you, hey, you need to call the audio video plugin extract audio. Then semantic kernel called that plugin, and the interesting thing, you have the third message in the list, and this time the message role is tool, where semantic kernel plays the tool call ID to correlate the ID of the call, and the content is the output of the tool. So basically, we are now telling GPT, hey, that's the question of the user, then you tell me to call this tool. I've called this tool, and this is the output of this tool, and what do I need to do now? And this time, the response is stop, because you reached the solution. If you see the response, now it has a finish reason of stop. Okay, that's the standard finish reason of a prompt, where this time GPT determined that you don't need to call anything else, you don't need to call any other tools, and it gives you the answer. The audio has been successfully extracted, and you can access the extracted audio from the following path, and gives you the path where your plugin extracted the audio. So basically, is the GPT, is the analyzing of prompt by GPT that determine that after all the sequence of I have a question, I give you the tool that you need to call, semantic kernel call the tool, here's the answer of the tool, and GPT determine, okay, now I've satisfied the question of the user, we can stop. Now let's do a slightly more complex example where the question is, I want to extract full timeline from a video file. And so as you can see, it gives me a timeline, and now the interaction with GPT is a little bit more complex. Now, as you can see, the first call is the same as before. The semantic kernel asked to GPT, hey, this is the question. The user wants to extract a timeline from the video. And so in the first step, GPT determined that you first need to extract audio. Then, as before, it do a subsequent call to GPT telling, hey, that's the original question of the user. You told me to call the extract audio. I've called, and that's the result. What do I need to do next? Now GPT knows that you need to extract the timeline and you've extracted the audio. So the answer is, hey, now you need to call another plugin, the transcript timeline plugin, and the arguments are taken from the chat and is taken from the output of the first tool call, the extract audio. But you're not doing anything predetermined. It's the GPT capabilities that analyze the sequence of plugin call and determine that the next step is extracting a timeline, extracting the transcript. Then you perform a new call on the GPT. This time you see that the second column is very, very long because the prompt is becoming complex, because simply the chain of messages is enlarging. So now the GPT call contains all the interactions. So I have extracted the audio, then I've used the transcript timeline, and that's the timeline. And the answer, you can see the answer of GPT is now you need to call the video timeline creator, because now you have the full timeline, the full transcription of the video. And if you want the timeline, you need to pass again to a large language model, to another plugin for compressing and extracting the sections. And this things goes on and on again. So each time semantic kernel it had called the plugin successfully, it continued to ask again to GPT, adding the new information. So I have the first tool call, then I have the transcript timeline. So I have all of my content, and then answer tool call. So you need to publish video timeline creator. So now I say, hey, I've called the timeline creator, and I've called the extract audio and the transcript timeline, the video timeline creator, blah, blah, blah. So I have all the things that happened in the past. And this time, the raw response is stop, because the last plugin, the summarizing timeline, created what the user is expected, the timeline of the plugin, the timeline of the video. So it can give you the full content. I have extracted the full transcript. So you have the ability to look call after call what is happening. And if it's not the thing you are expecting, you need to probably change the description of the plugin, of the parameter, because the description of the plugins and the description of the plugins parameter are the only things that matter for this kind of interaction, because these are included in the row request. In the end, there is all this description. You see the description of the parameter is what giving the GPT the idea of which kind of plugin you need to call to accomplish the question of the user. You can also add other diagnostic information like the total token used. And if you want to understand how much text was given in input, I've added the total prompt tokens, so you can understand how much does it cost with the call to the API. And this concludes the video where I've examined how you can intercept all the HTTP call and intercept especially all the call to the OpenAI API, so you can parse request and response and give to the user a nice timeline of what happened. And this is not something you should give to the end user, but it's important to troubleshoot the thing. So in my example, everything is kept into memory, but I'm planning to expand a little bit, just saving all the interception in a MongoDB collection or into a database. So if you have a user that asks something to your copilot and the answer is not what they expect, you can look and understand exactly which sequence of call semantic kernel perform to GPT to come to the solution. And so you can change, probably you need to change the description of your tools. All the nitty-gritty details are in the code, so you can download the code, experiment by yourself, and verify and modify, do whatever you want. I hope this video was good, and I hope you enjoyed this video, and I'm waiting you on the next one. Bye-bye.